everybody, hello, welcome to LiveCast number 11 for Arduino. Today, considering it's a holiday in most of the Western Europe, it's been a bit of a challenge to make it on time. So today we're going to have something that has to do with music. I'm going to do a new thing every now and then. I'm going to be taking an existing kit and I'm going to just show you what it is that I'm talking about. And this is a kit. Oh, the camera is not really well centered. I had to like rush into the studio, and so things aren't exactly in place. So let me just straighten this up. There you go. So this is a kit from a designer that's called Michael, and Michael makes these designs under a label called Nootropic design. I'm just like moving things around to center things on the screen. There you go. And so I discovered this kit long time ago when I was like checking around on Tindy, and I thought to myself, oh my god, I need to have this. And so I bought it. And so just to make it very clear, there's absolutely no association. I guess Michael has like no idea I'm gonna be showing this here today. I bought this kit over a year ago, but I've been really busy working and I never had a time to put it together. So I decided today I'm gonna be putting it together. And so it's gonna be a bit of a different kind of live cast, where I'm not gonna be necessarily like presenting things. I'm gonna be just like mounting something. And I want you to be aware of how my studio looks like a little bit. Well, it's a bit of a mess because I just moved into this place, which is literally the shed in the garden. And I guess it's the place that every maker wants to have. I don't know, at least it's what I think. When we moved here, and so we had this thing, everybody said you have to throw it away, and I said like, no, we have to keep this. And I'm gonna just show you with the camera very quickly. I will just dismount the camera from the stand, and that's like my soldering iron, which is my absolute favorite brand for soldering irons. And there's a second room in here down there where I have like you can see it, but I'm still unpacking boxes, and there's like more boxes, and the studio, like the screen with the chat, and there's OBS, and some more boxes, and that's me. Woo! So there's gonna be a lot going on in here, and I'm gonna be doing a lot of live casts from here, mostly because it's very easy for me to just set up everything and keep it in a kind of like sane way. And it will also allow me to do special things like taking stuff and mount it live and just check how it works. So well, you say the real hackerspace. Well, it's gonna be Brumla says in the chat. For those of you that aren't seeing this, I will just like, here you see the chat, and I remind you we have a chat where you can join, and you'll see in the upper corner in the screen you see that there is the URL to the chat on Discord, and that's always open. It's open 24/7. There's people from all over the world that are slowly joining the chat, so feel free to come in. And we have a couple of channels, and we have a very strict code of conduct, so please, let's avoid doing any kind of marketing, any kind of harassment of any kind, like not being upset. Those things are for other places. We want to have an inclusive place where people can come and discuss about Arduino related questions, making related questions, and where people from all over the world are welcome to meet in a more of like an immediate way. So if you want to like solve complex technical questions, please go to the Arduino forum. We just want to like hang out with friends that have that are like-minded friends that they'd like to build stuff together. Like, join the chat. And we're in the LiveCast channel, so if you join under the general channels, this is URL for the general channel. You should click on the channel, and here we'll be having this LiveCast. And as I said, every now and then I'm going to be like getting anything that I find interesting. I will make like a personal review as I mount it, and I will try to get things that can be mounted in an hour, so that the LiveCast doesn't last forever. And this one, as I said, is from Nootropic design. And I realized now I need to open a browser here so that I can search for it. So here you see the browser, and Nootropic design is written like this. And you can go to nootropicdesign.com, and so Michael here. Well, let's first see the about. So here, Nootropic Design LLC is a small technology and design company based in Minneapolis, Minnesota, United States. and design and manufacture innovative electronics for hobbyists, designers, educators, and industry in general. And it's Michael that is behind it. And so I got this kit a while ago on Tindy, as I said. I had a small issue with transportation, mostly because I was traveling when the package arrived, and so I completely missed going to pick it up. And Michael was very nice and resent it to me once more. And what I got was this Arduino Shield for real-time audio processing called AudioHacker. And just to put it on top of it, I got this DJ Shield. There's nice buttons and ports for the Arduino, which is recommended to put on top of the AudioHacker Shield. So this is the Hacker Shield, the AudioHacker Shield, and the thing is I saw this picture with everything on top of each other, and I thought to myself, I want to have this. And well, you know, it's the maker in me, I guess I can say that. And it's a small small shield. It doesn't have a lot of components, so it will not take me a lot to solder it. It has audio input and audio output. You can bypass the signal. There's a volume knob. There is a couple of buttons to you can program them to add whatever effects and so on. And there's the different kind of like sound rates that you can, sample rates you can reach. And there is an API that you can use, which is the AudioHacker and so on. Okay, so sorry, I mean, I would say I would just start. I mean, I never did this live. I never, well, I've made tutorials, but never like this live. So I'm gonna just start putting this together, and I don't know, what can I say? Just get yourself a beer or a soda, whatever you prefer. I have here my bottle of sparkling water, and let's get started. So I will speak in a lot. If you don't know how to solder, hopefully this will be a good way to get started with soldering. And it's always recommended to start soldering like the first 2-3 things, like not on something you buy, but once you get started, then getting something like this is a lot of fun. And what I'm gonna be doing is to mount it and test it out. And if I'm fast enough, I will be able of testing the full design as you see it here in the picture. So, oops, sorry. Let's get started. I will have to change cameras, and here you go. I guess this is the right view. No, oh my god, what did I do with my settings? Ah, this is the one I wanted. Okay, so as I said, I have 2 different shields. One is the DJ Shield kit that can go either on top of Arduino or on top of the AudioHacker kit. And this, well, this DJ Shield kit has 3 knobs and 5 buttons and a couple of LEDs. And this one is a bit trivial to mount. I will do it at the end. And the other one is the AudioHacker kit, and it's the Arduino Shield for real-time audio processing. And there is instructions here that you can follow. If you want to see how to mount it, there's some instructions. So let's take a look very quickly at the instructions. It's the AudioHacker/build. So it's AudioHacker/build on the website. And okay, so if you have to get ready to solder, you need a soldering iron. I have it. Wire cutters, they're not exactly here, but in the next room, so I can get it in a second. Some tape for holding components in place while soldering, and so on. And then, as in many kits, when you get started soldering, there is the recommendation of putting first the smaller components and then going on. There are some exceptions in some kits. Sometimes you need to put some components in a certain order, because what's going to happen is that you're going to be like layering components on both sides. It's not the case of this shield, which is very well designed. It has a lot of space, so it has like no problem to put all the components. Some other designs that have less space, they have to use this trick of like layering things. And maybe one day we will mount a Arduino, for example, Arduino, which is a game console that has to put the screen before putting the microcontroller socket, because otherwise it's impossible to solder it later. So there's this kind of things. So first thing, we just have to open the package and bring out all of the components. Here you go. There's the shield and there's all of the small components. And there is, well, first there's the board. I guess if you can see it there, I can bring it a bit closer. Oh, the autofocus is misbehaving. I should probably just correct this on my camera. 1 second. Settings on the camera, and we will remove the autofocus. Perfect. So in this way the camera will not go crazy. So here you can see the shield, and you can also see it here in the browser. And what you see in the shield is that there is 5 chips, and let's take a look at this image. Make it bigger, like this. Perfect. And see, it has 5 chips, and it says here SRAM, DAC, ADC, op-amp. So for those of you that don't know much, or that might not know about sound technology, it is typical that you have to digitize the sound, and that ADC that takes a sound which is analog and makes it digital, and then you might store it in RAM to make some effects, and then you might it will translate it into analog again with the DAC, which is digital to analog converter, and then later on you will use an operational amplifier to just amplify the sound and make it as loud as you need for whatever effect you want to. So that's what the chips are for. And then all of the components you see around are just needed to make sure the shield is, or sorry, the chips are operating properly, like resistors, capacitors, or normalize the signal, or make low pass filter, or whatever else. So it's not a lot of components, and you just have to mount it carefully. You see there's a bunch of resistors there, which is the first step of mounting. So what I would typically do is to look for the resistors in the kit. I'm looking for them, and look for all of the resistors, and I will usually mount all of the resistors at once. So I have them here. Okay, here you can see in my hand, oops, all of the resistors at once, and I will just mount them very quickly based on the values. And if you have never built a shield or built anything, you will see that the design includes, you can see there, that includes the names of the components. So for example, this resistor is R6, the next is R7, and so on. So there is typically a bill of materials, which is how you call the list with all of the materials, and with that bill of materials you know which components go where. And here you see, oh sorry, I'm just not showing you that. Here is part of the description of the project. Here's the different components. There's a printed circuit board, there is sockets for the chips, there's the different chips, the amplifier, the analog to digital converter, the digital to analog converter, the RAM chip, capacitors of different types, and here we go with resistors. And in this part list it just tells you that the different parts are there, so you will typically check that all of the parts are there. I'm gonna trust blindly that all of the parts are here, just because I don't want to use a lot of time finding them. And then I will I basically need a different kind of part list that shows a relationship between the values of the components and the names of the components, because as you see in the list here, there is 471 resistor, yellow, purple, brown, gold, and there is 2 of them, but it doesn't tell you this is R6 and R5, for example, and that's what you would need if you wanted to make it very easy. And when I look around, I don't see it. Maybe it's in the about page. and I will just check AudioHacker about page, the Shield production page, usage guide, bypass switch, the library, the software. Okay, this is not here, so I'm going to assume that this does not exist, but it's still not a problem, because if we have a picture of the different steps, like the assembly instructions, like here, I can make this again a little bit bigger. Actually, in the text it says, here you have it. Okay, at some place it has to say, I just didn't check this out, I'm just doing this thing live and I haven't rehearsed, so some things I'm going to be discovering. It's okay. So it says here, R3 and R4 are 100K with color code brown, black, yellow, gold. So I have the resistors here, and I'm going to just see that R3 and R4 are 100K, which is brown, black, yellow, gold. So it's brown, black, red, brown, black, yellow, gold. Okay, I have one of them, and let's see if this is another one of them. Yeah, so I have the two of them. So if you have both resistors that are the right value, you just need to fold them. The footprint for the component is typically the same size as how you fold the component, and just punch the terminal pins in the holes, and then on the other side you open the legs a little bit so that the component will not fall. You can continue to mount the next one, and there you go. Next component, and very easily punch it in. It says there R1 and R2 are 470 ohms, which is yellow, purple, brown, gold. And I move the components to this part of the table. So it's yellow, purple, I have one, and the other one is this one. Yellow, purple, brown, gold, and these are R1 and R2. So I fold the components, and R1 and R2 are on this corner of the board, and there goes the first one, and then the second one. So I have to say, when I was little, there weren't many kits available where I lived, but they were the Commodore 64 magazines, and I bought a Commodore 64 magazine that said how to make an LED panel, like the one I was showing how to mount in the previous program, and I was very excited. So so I mounted my LED panel and connected to my Commodore 64, and I burned the chip like a world champion. Okay, but I made everything. I etched the circuit, I made all of the steps one by one. It was very, very exciting. It took me almost a year to fix my computer. Okay, this is R5, which is 1K. Here you go, R5, which is 1K. I punch it in, and there is only two resistors left, which are R6 and R7, and it's exactly two more that I have on the table. So I have the exact amount of parts, which is very nice. And they have to be 100 ohm, which is brown, black, brown, gold, and it's exactly what it says here. So I just double check. It's important to just make sure, because sometimes you just mount things blindly and all of a sudden you get surprises, because mistakes might happen, for example when packaging. So here we go. When we made Arduino, I thought it was very exciting, the idea that at some point people will make like things like this shield I'm mounting today. This is an indie initiative, so it's extremely nice for me to like find things like this. It's a huge pleasure to like say, oh, I would like to make something with sound, and all of a sudden you find this ready-made thing that you can build very quickly and you know, and have fun. So I'm gonna move from this camera you see me here to just get closer to the part where I'm mounting things, just to make it easier for me to solder and avoid any kind of accidents. Because when soldering, it's important to focus. And the one thing I don't have is air extraction in this room, so it's gonna be a lot of fun, because you're gonna hear me blowing, as I solder, because that's the way I solder. I learned to solder when we didn't have like a lot of protection equipment over 30 years ago, and or even more actually. And so I learned to do it by blowing constantly on the circuit, so that the fumes from the metal don't go into my nose. So here I am. My soldering iron is just here outside the picture. You can see it. It's a microcontroller controlled soldering iron that changes temperature super fast. It's fantastic because it goes from 0 to 380 degrees in just 10 seconds. So it's extremely practical and very, very good. And so I'm going to start soldering. Here's my soldering materials, which is lead free. Everything I use, by the way, it's ROHS, something that is, you know, I grew with like non-very environmental friendly components like everybody in this business, but these days I think it's important to just make the best you can for the environment. And since actually our job is not very environmentally friendly in general, I think we have to do as much as we can to respect all regulations. So if you solder with lead-free soldering, it's a bit different from soldering with lead. Among other things, the materials, it's more important to heat them up fast. So you have to like heat up the metal and then just bring in the soldering. And you should develop a skill especially to solder components that are connected to the ground plane. And this has to also do with design. So when somebody designs something, they need to be careful. And when they design components that are going to be soldered by hand, they should make sure that they don't attach huge ground planes to the pins where people are going to be soldering at, because it makes it very, very hard to solder the pin, especially if you're a novice and not an expert. So it's important, guys, if you're designing circuits using KiCad or Eagle or whatever, that you take this into account, and when you design ground points, that you put across and you isolate a bit the pin, because otherwise it's going to be really hard for people to solder the components. It's very easy to hit a pad, but it's really hard to solder a ground plane, or to hit a solder ground plane. Okay, so now I just solder all of the pins very quickly. And as you saw, what I did is that I put all of the resistors at once because they're the same height, so it's very easy to solder. And I just like very quickly solder all of the components. The next thing I will have to do is to cut the different pins with the pliers. And you're gonna have to excuse me for like 10 seconds because I have to stand up and get the pliers from my shelf. Oh my god, I'm hitting the camera all the time. And please feel free to just comment on the chat or anything. And I think it would be really nice if, since there is a lot of people that are connected, and I bet that you have your own soldering techniques or designing for soldering, if you commented on experiences, because this is what it is all about, is to learn together. So just excuse me for a second while I find my pliers. Okay, so this is interesting. Somebody has taken my pliers away, which means I misplaced them, because obviously nobody came here to steal my pliers. So I'm gonna use a scissor. I mean, it's not recommended to use anything that is not a good plier to cut piece of metal, but given the circumstances, you see here, I can perfectly use this scissor. This is a pretty strong scissor. It's meant to be cutting strong cardboard, sometimes like thin wood, and definitely metal as well. It's just that the finishing is not going to be optimal for the pins I'm cutting, but you know, I will live with that, and later when I find my pliers, I will revise the pins. And once you have solder, you can cut them pretty short. You know, it's you don't want things sticking around. And okay, that's done. So let's just then go to the next component. After the resistors, according to the instructions manual, you see in here they have pliers. You should look to mount the sockets for the chips. And mounting the sockets for the chips is kind of important because if you were soldering the chips all at once, if you're soldering the chips directly on the board, imagine you solder it wrong. It will be really, really hard to dismount it. On the other hand, imagine it got broken. It will be really hard to fix it. So having also by soldering, if you're not an expert in soldering, you might overheat the chip and that might damage the chip. So it's important to basically do it, or sorry, use sockets whenever you use chips, unless you have very little room and you can't use them. And I'm always talking about through-hole components. If it was surface mounted, it will be a different story, because then you will most likely not use sockets. Like, there is sockets for some surface mounted components, but they're expensive. So a very important thing that is very well explained in the manual is that you should be very careful and look at that the sockets for ICs, for chips, they have a small mark, and the drawing also has a mark. So you should just mount them respecting the mark, because I will also give you an idea on in which way you need to mount the other components. You need to put the chip in the socket once you're done. So how can you turn this thing back now? They're always gonna fall. So I always look for something like my candy box. I can just put my candy box and there you go. And then again, the only thing I need to do is to solder all of the pins. If you're again a novice, it's recommended that you solder one corner first, like choose one corner of the chip, whatever corner, just to make sure it's stable and that it's like everything is kind of horizontally placed, and then you can solder the rest. Okay, so I'm just talking while my soldering iron heats up. It's been with me for many years, so I think the sensor for holding the soldering stick is broken, so I have to activate it by hand. But here you go. So you can start soldering again. So just heat up the pad and then bring in the soldering paste. I'm gonna just make one corner for each chip so you can see exactly what I'm talking about. And there you go, the corner for this one and this one and this one. Okay, I will lift it. You see, I soldered just one corner and it's enough for it not to fall. I forgot to solder one of them, but you see the idea, right? So it's a way to just have them on a safe position, because then you can move them around easily and you can continue to mount them. It's not a problem. So I just add some soldering to this one as well. And now all of them are safe. And you see there is like no separation between the socket and the board, even though I only solder one pin. So then it's important you solder all of them. So we just solder all of the remaining pins, and here you go, one more. And I have to keep on blowing the fumes. At some point I will have to buy an air extractor for this shed. And another one, and another one. And here we go, once more. And it's important you don't forget any of the pins, because the reason why you solder is not to have the components like mechanically attached to the board. The reason why you solder is to have an electrical connection, and if you don't solder properly, then there will be no electrical connection. If you forget some pins, they might be touching sometimes, and so it might be working sometimes, and sometimes it might not be working. So a typical mistake or a typical bug that sometimes happens is that one pin is not soldered properly, and so the circuit is sometimes working magically and sometimes it's just not working and you don't know why. And it's just about looking for the pin that is not properly soldered and just reheating it up. And this is again something that happens even with SMD components. Sometimes you buy something and it's not really working and you realize it's one of the chips that is not functioning, and maybe it's just bad soldering, and just by reheating the pins you just fix a problem that is making the system not functional. So now I soldered all of the pins, and it's important to visually inspect that you didn't forget anything. And yeah, everything is being soldered in the right positions. And then again, don't put the chips now. You don't need to do that. You know, the chips is the last thing you're going to put. When everything else is mounted, then you will put the chips. You just put in the sockets because it's the next thing in height after the resistors. You see, the resistors are the lowest ones, and then comes this one, and then it's the rest of the components. So let's take a look at what is next in the list. And let me just show you the browser, and let me just, because I'm having the chat window open on top of everything. You don't see this because it's on my computer, but I have it and it's not letting me see. So the next thing is to put in the capacitors, and these capacitors that are put by the placed by the chips are called decoupling capacitors, and they're very needed both for digital technology that might produce like small spikes when it's switching, and those spikes might affect sound. And since it's a circuit that is used for sound, it's important to put it there. And you will see that in the design, the capacitors are just by the chip, and the idea is that they are connected between power and ground in the chip to make sure that when there is a spike of whatever kind inside the chip, it's absorbed. Or if there is a spike coming from somewhere else in the circuit, instead of affecting the chip, it will be absorbed by the capacitor, and it will stop the capacitor potentially failing. And you see that there is only 4, and it's the 2 memory chips that have it, and then there is the digital to analog converter, and there is the operational amplifier. But I bet that there is C4 that is by the analog to digital converter that is doing the same thing, but it looks like the analog to digital converter needs a larger capacitor, and so it's not using one like the one we're going to use right now, which is a polyester capacitor or ceramic capacitor. I think this is ceramic. And so these ones are very tiny, and they have no polarity, so I have to like remove them from the cardboard that holds them. They come always glued to a piece of cardboard this way, or not always, but this is a very common way of serving capacitors. They're made in really long stripes in the factory, and they come by the thousands. And I look at the picture. And here you go. This one comes here. And it doesn't matter if you have a bit of glue on the tips, by the way. You see, you can barely see it, but there is a bit of remaining glue on the tips of the component, because I'm gonna punch it in the board, and that glue is gonna be really far from the part I'm gonna solder. So you don't need to waste a lot of time like looking at tiny details like that. You can just like very quickly punch in the component and solder it, and that's it. As long as there is no dirt around the soldering point, then it's no problem. And sometimes not even then is a problem. So you put in all of the components and so on. And you see, this is the way you solder through hole components. It's quite different from how you solder surface mounted components, where there is different techniques, and it requires that you don't really move the board back and forth, and you just keep it in a single place, and you know, like place the component and so on, because if you're moving it, the components are going to fall and it's going to be impossible to find them. But here the terminal pins allow you to move the components around without any problems. Okay, so let's solder these ones. Again, you see I'm waiting for a second, and it's because soldering iron needs to heat up. If you don't have a microcontrolled soldering iron, probably will be ready to go, but will also be not so good because it will always be warm, and that might be a bit dangerous because you might forget that it's there. So I'm a big fan of nice tools, and especially nice soldering irons, because I use them often, and I need to know I can work with something that functions for me. Okay, there you go. And okay, you see I'm cleaning the soldering iron's tip every time I solder, because this is one of the things that happens with soldering irons that when you work with lead-free material, the tip gets destroyed, and people try to use acid and so on. You should not use any of those things. You should basically use this like metallic sponge. I'm gonna show this to the camera. You know, this metallic sponge, to just remove the soldering leftovers from the tip and make sure it's clean every time you solder. And if you do that, you're gonna have a really long living soldering iron tip. If you don't clean it often, then it will get destroyed. And if you use things like this old school like paste that you use to clean the tip, that will not really work when you work with lead-free soldering irons. It will destroy the tips. So please don't mix technologies when it comes to soldering. You know, buy the right materials, and you will have a lot better experience working with it. Okay, so here you go. So I just put those capacitors, and let's see what the instructions have to say about how to move next. Okay, it recommends mounting the three big capacitors, which are these ones. These are called electrolytic capacitors, and the difference is that in a similar amount of space, they can hold a lot more current. And there is also a ceramic capacitor, sorry, a polyester. No, this has to be ceramic. It doesn't say. Let me just see the instructions because I can't read them. And the instructions, it says 10 microfarads, C1, C3, they are polarized. Well, it doesn't tell you that's electrolytic capacitors. If you don't connect electrolytic capacitors properly, they explode. So please be very careful. And there is a 1 microfarad capacitor that goes near the ADC, and that's it. Oh, further up here, there's the ceramic disc. Exactly, there you go. It's a ceramic disc capacitor, and this goes above the resistors. Okay, so the ceramic disc goes up here above the resistors. We put it there. We open the legs. Then C1 and C3 is 10 microfarads, and they're identical, so they have to be these two here. And you see, unlike resistors, where in resistors you don't see the value, in capacitors the value is typically printed, so you're not gonna see it, but it's written up here. So this one, it says here 10 microfarads, and this other one is also 10 microfarads, so it's the right one. And when I said you have to put them in the right position, typically in the circuit there is a small point marking the positive pin or the negative pin, so you will see a plus or a minus. So the plus is going to be the long pin of the capacitor. So the 10 microfarads capacitors, they are C1, which is this one, and C3, which is at the other side of the board, which is down here. Okay, and after punching them down, the thing is that these capacitors, because of the mechanical shape they have, the pins in the drawing are, you see, in a position so that when I punch them in, they don't fall. So I don't need to do anything to fix it, unless I think it's gonna be hard to hold them later. So then I could just like open the pins like I did with the other ones. But this is very common capacitors, like the distances on the pitch between the pins in the mechanical construction doesn't really correspond to the one in the drawing. So when you punch it in, they hold basically because the openings are different, the pitches are different between the drawing and the actual component. Okay, and finally is C4, which is a 1 microfarad capacitor, and this big one is 100 microfarad, so it's not, and this very tiny one is 1 microfarad, and this has to be C4, and C4 is here, and so I bring it in, and I'm ready to solder these 4 components, and you can solder in error again. I'm gonna have to wait for a couple of seconds, but the one thing is like as usual, I just came rushing to make the live cast, so I couldn't prepare really well, but I could program my soldering iron so that it has 3 modes. So I could have one mode that is always at 380 degrees, or maybe at 300 degrees, so I don't have to wait until it warms up. Because right now, basically, it goes down to 200 degrees, and if I talk for too long before I hold it again, it will potentially go to 0 degrees or room temperature, and then it takes more time to heat it up. So here I'm having this problem that I explained. It's a bit harder to solder because that one pin is a ground pin, and I will just draw this just to explain what I'm talking about. So there is the pad, and the component is coming through the pad, right? And this is the pin, the terminal to this component. But this pad, sorry, is ground plane, so it's connected to the whole rest, and this is all metal. So when I come with my soldering iron here and I heat up this one, it's heating up a ring, I'm heating up the ring and everything around. So to melt the soldering tin here, what happens is that I can't reach the same speed, I can reach the same temperature for melting, because everything else here is, it's a lot more metal to dissipate the heating temperature. So if it's just a ring, if this was designed differently, if this was designed being a ground plane like this, that left making sure that the positive pin is in the right location, and you see that like this, lying on the side, and I open the pins so I can solder the component. And if I wanted not to have like a big distance from the board, I can just put something to make some weight. And I will now solder this one, and this will be the last capacitor. And while we wait, after the capacitor, I have to mount the buttons. I'm just gonna very quickly browse through it because time is running, and you see already how soldering works. I don't think I need to bother you too much with this. So you will mount the buttons, and then the preamplifier gain, which is basically a potentiometer that you use to change the gain in the operational amplifier, which is the one that changes the volume. And there is a switch to turn the thing on and off, and the sound jacks, and then you're more or less done. The last thing is this. Okay, so I will just start by soldering this one, and then I will skip a couple of steps by just adding all of the components at once, or as many as I can, and then just soldering them together real quick. So here we go. I mounted this one, it's done. I cut the pins, there you go, and then bring in the 2 buttons, or the tactile switches. Naming this thing is always a challenge. Oops, I made a mistake. I was very brutal, and I managed to destroy one of the pins of this tactile switch. So I bring it out and put it in again, and there you go. The next thing is gonna be the potentiometer. Here's this, or trimmer, depending on how you want to call it, and just the sound jacks for output and input, which are a bit more challenging to mount because they got a bit, like the pins got a bit folded during the transportation, seems like. So you just need to punch them in. And this one, no, this one, and the other one is gonna go quick too. Perfect. You see, so these are all the components that are missing besides the pin headers, and I'm going to just solder everything real quick because time is ticking. And then I will show you my trick to solder pin headers for shields, which basically consists in using an Arduino board as a way to hold the thing underneath. And later I will see if I can mount this other one real quick, and then we can test the software. I'm actually really excited I finally get to mount all of these things. So here we go. I'm gonna mount the thing real quick. So you're gonna hear me blowing a lot. So in the meanwhile, in the chat, I would like to ask people if you have like special ventilation or anything in your personal lab, because this is one of the things that I think everybody leaves for like the last thing. So I'm thinking that I have like an old vacuum cleaner that would make for a perfect air extractor, and I will just mount it like outside the window, and when I start soldering, have like a switch inside and, you know, extract the fumes. Because I also don't want it to be very noisy, because that's the other problem. Like if I'm making LiveCasts and stuff, it will get quite noisy and it will not be so nice. So having air extraction here is a bit of a challenge. Well, for example, at university we have these very expensive but very nice air extraction systems with carbon filters and a robotic arm that you can just move around and so on. So I wonder what people are using in general, or people are skipping it altogether like I'm doing right now. So, and that's the last pin. As you see, once you get used to these things, it goes pretty fast. It's very simple, and it's just about being a bit methodic and remembering the components you placed and where the pins are, so that you don't make mistakes and it gets easy to mount everything. Then there are some recommendations on the site that I checked about cutting some of the pins that are down here, because this is going to go on top of an Arduino board and some things might touch, but typically these pins are long enough so that there is enough distance for them to touch. And these pins are the last part that needs to be mounted for your shield to work. So you need the pin headers that, as you see, are a mix of male and female pin headers, what allows you to pile up different things on top. So these ones are meant to be putting this one as some sort of like a sound card on top of your Arduino board, and then have your Arduino, sorry, put another one on top of this one, so you could have controllers. And so the other shield I have there to be mounted today is also is going on top of this one, basically. Also, there is some extra things on this shield, like there is a pin header for carrying the SPI down here that it didn't come with it. I mean, it's not needed, but I mean, it's important to know that it exists. You could eventually have it. And there is a battery connector in case you want to just solder like a 9-volt battery. I guess I haven't checked where the power goes, but I would imagine that the battery input goes to voltage in. And there is some pins where you could solder wires if you wanted to solder the input and the output to this circuit. So this can be very handy if you're going to make a project where you're going to connect these things to different parts. So as I said, this thing is loose. You see the pins are loose, so it's really hard to solder this right. So even if you put it upside down, it's not going to really work. So what I typically do when I'm going to mount this is that it says to look for an Arduino board and mount the thing on the Arduino board, and in that way all the pins will be straight, and then I turn it back so that the board will be touching the end of the header, and in a way will be much easier to mount. So I'm going to just turn back here because I have Arduino boards in a box here, and I will just get one of those and use it for mounting. Okay, look what I have here. It's actually nice. I have an Arduino Mega ADK. This is not manufactured any longer, and this was made because Google, at the Google I/O some years ago, they they made a board that was based on Arduino Mega that could use Arduino Open Accessory. That is a protocol that allows you to send commands to Android phones. So they used this so that you could make accessories that could talk to Android phones through a USB, to the USB cable. And so we made this board based on their board, and it was very nice. We used it for a lot of projects, but it doesn't have a big audience, so we stopped making it. So basically what you would do is to just punch in the pin headers on the connectors all the way down, so that the shield will be in a situation like it will be when it's working, like this. And you see there is some issues here. You will see like the pin headers are not very long, so it's always going to have an issue. So you can always lift it a little bit like this. And so that the only thing you need is a bit of room, so you can solder a couple of pins and then eventually remove the Arduino board from the connection with the shield. Okay, you see, you need to have enough space so that you can solder things there, and just need to align them so they are the same height. Same thing on the other side. You just need to align them so they are the same height, but they are not all the way in, because otherwise this wouldn't be, the shield wouldn't be parallel. Oh, sorry, I'm just looking. Shield wouldn't be parallel to the board, and it wouldn't work. Okay. So what I'm gonna do next is just solder a couple of the pins, so I can then remove the Arduino board altogether. So this is a bit trickier, and you're gonna see me soldering down here, but it's not a big issue, so it's not that hard. I'm gonna see if I can put a camera like here, and you can have a different view of what I'm doing. Let me just hold it here. Okay, here you go. And let me see if I can focus a bit farther away. And I'm gonna see if I can just turn on the autofocus to make this thing a bit nicer. And camera controls, autofocus, go. Okay, now it's better, or? Okay, so so now I'm gonna be soldering. I have to excuse me because I don't see. I'm using the live transmission screen to see whether you guys are seeing what I'm seeing. And I see that, okay, this is not so sharp actually. So I'm just gonna change it again. And remove like this. Okay, perfect. Now it's a lot better. So here we go. So I will have to do the same thing. I just heat up the metal. Try not to touch the plastic because this will melt the plastic. Remember, the tip of the soldering iron is at 380 degrees. So I will just like heat up the metal and bring in the soldering paste on the side, you see? And this way you can mount the pins aligned in a very nice way. And if you don't solder all of them at once, it doesn't matter. You can revise, you can resolder or revise the soldering later. Just remember you need to solder a couple of them so that they are mechanically attached to the board. Every now and then, need to clean the tip. Here you go. And that one is hard to solder because that one is on the power connector and is I think it's reset. And again, if you have a lot of problems with one pin, you know, don't bother. Just like go and continue with the others, and you will have time to make it in a much more comfortable way later on once you have removed the board from there. So let's just solder some more of the pins. Not clean it properly. There you go. Now. And in the last pin header, I will just also solder a couple of them. Okay, so now I will just remove the Arduino board from the equation just to make it easy for me. And you can see, like, not all of the pins are soldered, but what I'm going to do is to solder what is missing very quickly. And now that I did the hard part, it's very easy to just finish this up. Here you go. Another pin that was missing from the other side as well. And now we're ready for visual inspection, which is super important. So every time you mount something, you need to take a look at all of the pins, what soldering paste or soldering tin, sorry. All of the pins got soldering tin, and there is no cold soldering, which would mean that it looks like it's soldered, but there is no real metallic connection. So here you go, shield number 1 is done, and the last thing to do with it is to just add the chips on the sockets. And I can't remember which one is what. I just remember that there is 2 chips that are RAM, so the 2 chips that are the same, and they will be going together. These 2 are the same, so these 2 are the RAM for sure. So the way I will put the chip is that first I just straighten up the pins like this a little bit, and then just punch it in the right socket. And remember the round mark on the socket. There's also a round mark on the chip, so it has to be placed in the same direction like that. And the other one, here you go. So that was the RAM. So the other 3 I can't remember honestly. So I will go to the instructions again, And if you remember, there is the part list is one of the options here, and it tells you the actual name of each component. So this is the op amp. It's called TS922 or TLV2462. So I will go here and look at TLV2462. So this one is the op amp. So this is the op amp, and I will just prepare it here, and the op amp is down here, so we'll just punch it in. There you go. And then there is the digital to analog converter and the analog to digital converter, and again go to the browser and it says ADC is MCP3201, and so it's MCP3201. So this one is the ADC or analog to digital converter, the one that will take signals from example for example from a microphone and bring it in. So this is ADC, and obviously the last one is the DAC, was the digital to analog converter, which is the one that after finishing the digital sound treating or processing, it will send the signal out as an analog output, so you can connect your headphones or connect to a mixer board or whatever. So here you go. So now there is the digital to analog converter, the analog to digital converter, the RAM chips, the operational amplifier, the bypass switch, the volume, and the volume. Oh, look at this mistake. I forgot to solder the volume. You see what I mean? So this is very common. You start mounting things, you get super happy about stuff, and you forget to solder something. And this is something you need to avoid because otherwise it gets very frustrating when you start writing software for stuff. So the electronics, as much as possible, should be functional very quickly, because then you can focus on writing the right software for them and make them function nicely. Okay. So now it's done, 100% done. This shield is completely mounted, and I'm not gonna try directly. You could just, like, you know, get super happy and go straight to test it. What I'm gonna do is I'm gonna mount the other one, the Nootropic design, like the DJ Shield kit, which is buttons and potentiometers for Arduino. And again, you see here it has a website, DJ Shield build. So let's take a quick look in the browser to where this is, and instead of AudioHacker, this will be DJ Shield. And there you see the DJ Shield is the shield, LEDs, buttons, potentiometer, knob. So this is going to be quite fast to mount. There's not a lot of components, and this is the instructions manual for the previous one, and I will just add here DJ Shield. It's nice that Michael here has the same structure for the whole website, and it starts by taking the two resistors that are 220 ohms and so on. So I will just open the bag, get out all of the components. Nice. Put the bag down there. Here's the shield. Very nice. I like this. It's very sober kind of logotype for Nootropic design. Very simple. And I think he's using Eagle's vector typeface, because it's the nicest looking of the typefaces on Eagle, I have to say. And it's very nice, very simple. Here are the knobs. This is two LEDs, because there is two LEDs, I assume there is two resistors that are needed to drive the LEDs, 3 potentiometers, 4 buttons, and button leads. So the first thing, according to the instructions, is to mount the resistors. Directly after the resistors, it's the LEDs, and after the LEDs is buttons and knobs. Okay, and you see it's very fast. It is very quick to mount. So I'm going to I'm going to use my magic superpowers, and I'm not gonna put the LEDs first. I'm gonna put the buttons first after the resistors, because I believe that they are slightly lower in height. Actually, I'm mistaken big time. Look at this, my friend. Actually, the LED is lower than the button. So, but I'm still gonna mount the buttons first, because there is 5 buttons, and they will give some stability to the whole construction. So I will first put the resistors, then the buttons, then the LEDs. I can even probably put everything at once and solder everything at once very quickly. And in like 5 minutes, I have mounted this shield, so I can then jump into trying software. Okay, here we go. And the different buttons. Button number 1 and 2 and 3 and 4. I really like the way these buttons work. One of my students just made a very nice keyboard. Probably I will mount that one at a different session. He gave me the keyboard, one of the PCBs as a present, and told me to buy the buttons. But I think it's a very interesting thing. So here you go. I was just checking the chat in Spanish, by the way, and I saw that Gustavo, thanks for coming. I know you're sick today. Was commenting in Spanish that he solders in a similar way. He puts the Arduino board, he solders the first pin in one of the corners when he puts the pin headers, and then he takes the Arduino out to avoid any kind of accidents. So so now the LEDs come, and remember the LEDs have polarity, and in this circuit the LEDs are marked with a plus sign, as you can see there. So the long leg goes to the plus sign, and I punch it in all the way. And I'm going to open the pins a little bit just to make it easy. And here comes the other one. Second one, and I will just again open the LEDs. I mean, it goes without saying that these techniques for soldering, they are applicable to all of the circuits. So it's not like there is some rare exceptions, but once you learn how to solder, it goes like this all the time. So if you want to start with soldering, I would recommend you just find a kit that you like and mount it, both because it's educational, also because it's fun. When you see the thing working, it gets really fun. So I'm gonna just be doing this very quickly. So you see, heating up the pad, bringing in the tin. And it goes without saying again, I'm right-handed, so I hold the iron with my right hand. One of the nice things with soldering irons is that they are designed to be working for both right and left-handed. So you use your stronger hand for holding the really hot tool to avoid weird accidents, and I use the left hand just to push in the soldering tin. Okay, So right now I'm about to finish all of the buttons, and this is the last button pin done. So now is the resistors 1, 2, 3 and 4, and then next finally is the LEDs, which are a bit hidden underneath this big mess of pins. Done. So the next thing is just cutting away the pins. Unfortunately, to the podcast, to the LiveCast, sorry, I remind you that I couldn't find my pliers because I just moved into this lab, into this garden lab. So I have to use whatever I have in hand. So right now I'm using a scissor to just cut the pins from the components, and the LEDs. The LED pins are actually kind of hard to cut. They're resisting a little bit, and actually I managed to have a here, so I have to be careful with this. And oh my god, it's gonna be tough. Okay, I have to use 2 hands for that cat. And the last one, here you go. This is what pliers do real good and scissors don't do. So you see, it's not like so super mega clean, mostly because of the cat, but it's done. So the buttons are put in place. Next thing is the potentiometers, and these potentiometers are actually quite nice, and they have this really big mechanical holders with big holes, and they take a lot of soldering paste when you mount them. There you go. But you don't need to solder them, actually. You just need to solder the pins where the signal goes. These ones are just there for giving some mechanical grip to the component. And there you go, the next one, and the last one. Looks like they are too open. Let's see. These are 10 kilo ohms potentiometers that come with this kit. Typically we use those kind of potentiometers when we want to work with analog signals. They're really easy to use and so on. So this is going to go super fast, and in a couple more minutes we'll have soldered all of the components of this board, and we just, as well as the pin headers, because the pin headers are going to go very fast. So then these ones they take a lot of soldering tin. They're not really needed because, as I said, it feels like the hole is just the right size. So when you punch in the component, they hold it real well. I did anyway solder one of each just to make sure it doesn't move back. And that's it. So then you can just punch in the leads for the buttons and the knobs for the potentiometers. So in my case this will be red, this is white, this is also white, white. Oh, you know, I waited for over a year because I had so many other things to do before I could mount this thing. And when you mount the knobs, it's recommended that you put them on a certain direction, to the left, for example, so that you can then just punch in the lead for the knob and make sure it's in the right position. And these leads, they have a screw, so I have to tighten it up with a screw. It's you can see it there. See? So I need to stand up again and get a screwdriver, but I will do that later. I will just lift that aside, and then I need to mount the pin headers for the board. And the pin headers didn't come pre-cut. Some of them came pre-cut, but some of them just didn't. So I need to cut myself the pin headers in groups of 8. So one trick that I do, just not to be mistaken, is just do like this. I punch it in and I break it, and I broke it wrong. So I will fix it later. So here I need 6. So I put it in and I will just make sure I cut it properly. There you go. And this last one, the Arduino, the Shield has only 6 pins. I'm using a mega board that has 8 pins. So if I put the thing here and cut the same length, I'm gonna be doing it wrong. So I have to like put this one here instead, and then just put this one here and cut it the right distance. There you go. And just to fix this one quickly, I will put this one and just cut away the remains. As you saw, it's easy to do, and it's a nice trick. And you can just then bring in the shield on top of the tips of the headers, and then solder it very quickly. And once I'm done, in about an hour, I will have mounted 2 shields, and then in a couple of minutes I will just do some software. We'll just run some of the basic examples from the Nootropic design website, and I will call it a day. So the nice thing, if you make your own board, if you make it black, is that you're not really going to see the burns from soldering by hand. Because you solder by hand, there's always small burns that come from the paint that is on top of the boards. If you make white boards, for example, it's really hard, or yellow boards, it's really hard to solder them and not leave any traces. You have to be very skilled, and they don't look as clean. So if you make prototypes, I would advise is to use dark colored boards if you want them to look like a bit elegant, and also like matte. This is black but it's shiny, but the black matte boards, they look fabulous. So this is my advice. Like for the boards that I make for myself, I actually use purple and yellow, the stock colors. Because I want to distinguish which are my boards and which are everybody else's. So that's about the shield. The shield is now done. I will take it out. And the shield is supposed to go on top of the other shield, as you see. So one is the input mechanism. You have potentiometers and buttons and so on to do something with the sound. And this goes on top of an Arduino Uno, and then it's fantastic and makes some sound. So there is not a lot of time left. Well, I said much time as we want to, but it's 2025 and I need to jump into another podcast. So what I'm going to do is I'm very quickly going to look for an Arduino Uno, and I'm going to just make a simple test to see that this works. And if it works nicely, I will congratulate myself. I will give myself like a big thumbs up for a good soldering job, and I will thank you all. So just give me a minute. I will just get my Uno and my cable and be back. 1 second. And here we go. So now I have my classic Uno board with breadboard. As I said, I always glue them so I don't miss them. And I'm gonna change the camera from place. I will put the camera up here so that you can look at what I'm doing with your classic eagle eye view. And we just plug the shield, and I hope it will not catch any like fire or anything. Have my USB cable here. I plug it to my hub and to the shield. Lights are on. Things seem to be working fine. The shield seems to be working fine at first sight. I mean, working as in it doesn't catch fire, which is already something, considering that I mounted this thing real quick. So next thing is I need to check how you make sound with this thing. And here in the AudioHacker thing, there is some experiments, some very basic experiments that you can use. So I'm gonna take a look at the code part and see if I can just run some very basic code. So there is a library and there is instructions on how to install the library. If you want to see how to install a library, please refer to the Arduino LiveCast from last week, if I remember right, where we explain how to expand the Arduino software with your own libraries. And this is what you see now, the AudioHacker Arduino library that is on GitHub, and it has a couple of examples here. As you see, actually they look like very promising examples. So I also have, and you can see this, but I have this audio cable down here that goes to my mixer board that I use for the live transmissions, and I will put this one connected to the audio out on the shield so that we can see whether it works. So this table is going to have a lot of wires, and this audio output. So right now I will just turn off the volume for that wire because we don't want, eventually there might be noises when we program the board. So we just need to download the library, and I'm going to extract it in the Arduino sketchbook folder, as I explained earlier. So I have it in a, you don't see this, but I'm actually working right now in decompressing the file in the right folder. So I have my sketchbooks folder for the LiveCasts and their libraries, and okay, there you go. And I will give you the old view, and here you can now see that in my development folder, sketchbooks, LiveCasts, libraries, I just extracted the AudioHacker library, and here it is. And just for simplicity, I'm gonna change this to have the same name. Just AudioHacker, the same name as the h.h file. Again, if you want to understand how library works, please refer to our previous LiveCast. It's explained there. And so if I run Arduino now and I run it on the right folder, it should, with the right schedule folder, it should find that file. So I'm gonna just run Arduino here, and in short, you're gonna see here's the Arduino software, and it's having an example that I did. I'm actually making a synthesizer with a different thing, with a different music instrument. I will show this to you one day. And if I look at my own projects, this is not the right folder. It's an entirely different folder. So I'm going to be looking at the right sketchbook folder, which is LiveCasts. Okay, and here you have it. So now it's the right sketchbook folder, and it has the new libraries, but I need to restart the Arduino IDE just to make sure that the libraries are included when I boot. So now the new library is there, and I can browse the examples of the new library. So I can go to File, Examples, and AudioHacker should show up down here, you see, in the menu. And here I have a lot of different examples, like sample reverse, voice changer, real-time voice changer, multi-sampler, looper, filter, echo effect. So I don't know what to take. I will take the drum machine just to see if this works. Okay, so this was made in 2013, and it's a 3-track drum machine, and I don't know exactly how it works. I have never tried it out, so I just want this thing to play some sort of sound just to be happy and make sure that this works. And it's using different buttons, so I am assuming that it's using 4 buttons. I'm assuming it's using the DJ Shield that I just made to work, and this is it. So it says here, design. Track delay is not the delay between end of last play and beginning of next play. It's a delay between beginning of each beat. Track delay is a cycle count. So measure the time between beats, convert to cycles. Press loop button when the track button starts setting the beats. We enter the loop when press button is released and setting the beats. And it's using 3 potentiometers that we just installed to do the different volume shifts. Okay, it looks like this code is meant to be working with everything we just mounted. So I will just make sure I have the right board, which is Arduino Uno, and that I have the right port, and that I can compile the code. And if I can compile the code, I will upload it, and let's see if it makes sound. And if it makes sound, the rest is exploring how the whole library works. And I mean, I will not spend time in that today. My point was to mount a shield and prove that it works. And if it works fine, maybe one day I can have the David Quartier's orchestra and eventually play for you live. But I think I'll be too shy for that. Not that I'm shy in any possible way, but I mean, a bit shy for playing music at this time. Okay, so it just gave me an error, and it's exactly the same error I had last week, and this has to do with the way my computer is installed, so you should not have this error yourself. So I'm going to save the file into my own folder structure. So it's going to be LiveCast 11. And save. And see if we can compile now that it's in the right folder. Whoops. This is not what I expected. So I will close everything. Well, what happened to me last week is that when I close everything and I open it again, it just worked with the new libraries. So I suspect that I have issues with OneDrive. And I still have them since my first LiveCast, so I need to figure out how to sort that out. Okay. Some time to compile. it compiled. So it was exactly as I said. So now it's compiled, I can just upload it. So now the program is uploaded to the Arduino board. And once it's done, I can open the serial port monitor to see what's going on. And then I will just higher up the volume. The speed of the serial port, I think, was 1500. It was this one. Yeah, there you go. So I can press buttons to see what happens. So it's not using the buttons. It's not using the buttons that I have in the shield. So I wonder how these buttons are configured. If I have volume, we don't hear anything at the output. Well, there is something now. When I press this button, the light goes on, and this one, so it's detecting that I'm pressing 3 of the buttons, but that's it. Okay, so this example is not working for me. So I wonder what happens. Oh, track to recording time and address. Okay, so that worked. So the only thing is that I'm not having a sound input because this device works with a sound input. And I wonder if I have a microphone or something I can connect to it. Let me just check 1 second. Yeah. So I have a microphone. I will try to plug in this microphone and see if it works. And so since I have a sound input, I want to change the example to one of the simpler examples that were in the list. So it's AudioHacker voice changer. And this one is 8-bit voice changer for AudioHacker. So it's supposed to be, again, it has a record button, play button, record button is supposed to be 5, play button number 6, beta write, sample rate, etc, etc. So it's supposed to be able of recording a sound and then playing it back. Again, as you see, it's one thing is to mount the kit, a different thing is to try out the kit without having read the documentation, which is what I'm trying to do right now. So that is not very good. What I should do, and I don't have time for this now, I will continue with this in a later livecast, is to read through the whole documentation and see what it does, and then check what can be done with the examples, because the examples are not completely documented. But it says here basically that there is a lot of examples for you to test. So it requires a bit of experimentation, and that will require a couple of hours. So I think what I'm going to be doing is that I'm going to be making an extra live cast on this next week, where I will be just checking things out. But just as a way to close, I'm going to just show you what this thing does.
AudioHacker Voice Changer Project.
AudioHacker Voice Changer Project.
AudioHacker Voice Changer Project.
AudioHacker Voice Changer.
Hello, 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 hello. Yes. Yes.
Well, you get the idea. So what I will do for the next time, I will try the examples, I will prepare myself, and I will show you how they work. It will not be next week, because next week I'm going to be at a robotics competition in Spain called the RoboCampeones, and I will try to transmit live. It will not be at 7 CST this time, it will be in the morning. I will be transmitting, and there will be several hundreds of kids that will have made robots and will come to compete. I'm supposed to deliver a short speech there, so I will not be able to transmit the whole time, but I expect to be able to showing you some projects, some robots made by upper secondary or high school students. It will be really cool. So I will find some time at some point next week to show you how the libraries for this particular example work, just because I'm very interested, and in that way we can learn together a bit more about how to play sound with Arduino with a bit more complex tool using analog and digital converters and so on. So that was all for today. Thank you very much, and I hope I will see you next week. Thanks for watching, and if you have any questions, you know where to find us in the chat in Discord. It's in that side of the window, and it's open 24/7. We're open to listening to whatever you have to say and help you out with some of your projects. And finally, don't forget to subscribe to our Arduino channel on YouTube. See you soon. Goodbye.